Hello and welcome to another ScratchLink instructional video. Today we will be looking at the obstacle avoidance algorithms and coding the eBot to navigate around the place and not crash into things. So there's three algorithms. We'll start with the simplest one, which is just a single ultrasonic, and that involves turning away. It doesn't matter which direction, checking the ultrasonic and turning away if it sees something, otherwise going forward. Great. So the essence of that is a forever loop with an if then else statement in it. So we will get that started. There we go. Okay, so that's an if then else statement in a forever loop. So what we need to do is ask the question, does the ultrasonic see anything? So we're going to go down and drag out the, doesn't matter which ultrasonic you use. I'm going to use the left hand one for now. And we're going to need an operator to ask the question. I'm going to use less than and just pop that from the right hand side and then pop that in the if then else statement. And so that is asking, check the ultrasonic left hand side sensor, and if it's less than 30 then it will do whatever we put in the top code. So if it's less than 30 it means it's close. So we could just turn, okay, or we could back up and turn, but I'm just going to turn. So we go down to the eBot blocks and we want to do the drive block, and we can just do a hard right turn at power 50. Now if that is false, if the ultrasonic left hand side sensor, if its value is equal to or larger than 30, it means it's not close, so we can just drive straight. Okay, and that's it. Okay, so that's the first algorithm for obstacle avoidance or tunnel run. You can put up a bunch of obstacles and it can follow a maze basically. So the second one we're going to have a look at now is if we use two ultrasonic sensors. So when we're using two ultrasonic sensors, we're basically only going to go forward if both ultrasonic sensors don't see something. All right, so that's called basically a nested loop. So what we can do is that we can, I'll just zoom out of here a bit, we can duplicate this first if then else statement. And so what we want to do is, if you look at the algorithm, we want to check the left hand sensor, and if it sees something, if it does see something, then you want to turn right. So that's the same. If it doesn't see something, if the left hand ultrasonic doesn't see something, then what you want to do is just go and check the other ultrasonic sensor. So I'm going to pop that in there and take the left hand ultrasonic reporter block and go and get the right hand sensor reporter block. And instead of turning right, I'm going to turn left, okay, because it's the vague logic there is that if you see something in your right hand, then you want to turn left. If you see something in your left hand, then you want to turn right. Okay. Now, that basically is it. We don't need that anymore. So that's your two ultrasonic obstacle avoidance. So firstly, it will check the left-hand sensor. If it sees nothing, then if it sees something in the left-hand sensor less than 30, it will turn right. If it sees if the value is greater than 30, then it will go and check the right-hand ultrasonic sensor. And if that sees something, it will turn left. If it doesn't see anything, then it will simply go straight. Okay, so for it to go straight, the nested loop, for it to go straight, for the robot to go straight, it has to have a value equal to or greater than 30 coming from both ultrasonic sensors. Okay, and where you've got this two if then else statements nested inside each other, That's just called nested loops or nested if-then-else statements. Okay? And it's the simplest way to do it. There are many other ways to do it, but that's the simplest way to do it. Okay, great. Now the third algorithm is adding a bit of complexity. What we're saying is that sometimes the geometry of things driving around, something just, you know, or someone throws something in front of it. What if something happens where all of a sudden, you know, bang, there's something right in front of your face, and turning is not going to be enough to solve that. You might smack it. So why don't we say change the algorithm, which is the third algorithm, which is the close backup, is if something is closer than whatever you want. I'm going to use 10 centimeters. If something is closer than 10 centimeters, then don't turn. You want to back up. You want to back up and turn, so sort of, because you won't have enough room to turn. That's sort of the logic. So we can keep what we've got here, but before we get to this, we just need to check if we are close. So once again, I am going to duplicate those two. I'm just going to do this checking less than, that's it. So I've just duplicated that. So what I'm going to do is check if you are less than 10. So if you're really close on the left hand, then I don't want to do a hard right turn. I want to do a reverse turn. And the way I do a reverse turn is just make the power negative. Okay, so just make that negative 50 or whatever you want. Okay, so that's doing a reverse hard right turn because it sees something in the up close, less than 10, in the left hand ultrasonic. Okay, now if that's not true, then it's going to go and check the other ultrasonic, and if it does see something, then likewise we're going to put a negative in there as well. Okay, now this else is if both of those statements are not true. So if it doesn't see something up close in the left, if it doesn't see something, well, that's got to be 10, doesn't see something up close in the right, then what it can do is do the rest of the algorithm, which we can drag from down there. I'll just make sure that I didn't get any of that. There we go. I knew there was a spare forever loop there somewhere. So okay, so see how quick and easy that was. So what we're, oh no, I've lost my forever loop. So the forever loop needs to go back in there around the whole lot now. Thank you. That's it. So it seems complicated, but it's actually not really. It's exactly what we've done in the algorithm. So what we've got here is, first one we're checking is something up close in the left. If it is, then do a hard backwards turn. If it's not, then check the right hand ultrasonic, and if it sees something up close, then do a hard backwards left hand turn. And then in this else, if that's not true, then it means that neither the left nor the right sees something up close, in which case we simply do our normal algorithm of turning if we see something less than 30, or going straight if both of them are greater than 30. Okay, so that's it. Thanks very much for listening.